We are going to start now lecture 7 of chapter 7, class 11th mathematics, permutations and combinations. In this lecture we will discuss some problems based upon combinations. So first is, in how many ways a cricket 11, it means we have to choose the team of 11 players out of the batch of 15 players. So one thing is clear from this, that this is the question related to combinations and not of permutations, because the order in which the 11 players are selected, it is immaterial over here. We are saying if it would have been that we have to arrange these 11 players in an order, then we have to use the permutations. But now we are saying that we just have to choose 11 players out of 15 players. So we are saying we will use the combinations. So first is, if there is no restriction on the selection. So when there is no restriction on the selection, it means we have to choose out of 15 players, we have to choose 11 players, and this value is equal to 15 C4, and this is equal to 15 into 14 into 13 into 12 divided by 4 into 3 into 2 into 1, and the value we obtain, it is 1365 ways. Next is, a particular player is always chosen. So if we are saying that a particular player is always chosen, it means we are saying one player is always chosen. It is one case is there. After that, the number of the total players we were having, it was 15. Now the number of players left, it is 14, and one player is already chosen. So now we have to choose 10 players out of these 14 players, and the answer for this we will have, it is 14 into 13 into 12 into 11 divided by 4 into 3 into 2 into 1. The answer we will have, it is 1001 players. Next is, third case we are having, a particular player is never chosen. So we are saying if a particular player is never chosen, it means now we have total number of players left, out of which we have to choose 11 players. It is 15 minus 1, 14. So we are saying the answer we will have, that is 14 C3. So this is equal to 14 into 13 into 12 divided by 3 into 2 into 1, and the value for this we have, it is 364. So we have total 364 options in this case. Next is, in how many ways can a committee of 5 members be selected from 6 men and 5 ladies, consisting of 3 men and 2 ladies? So what we are given, we have 6 men, out of which we have to choose 3 men. If we have done this, the next step we have, it is, out of the 5 ladies we have to choose 2 ladies. Again, the ordering is immaterial, so we are talking about combination, we are not talking about permutation over here. So the answer in these cases we will have, the answer we have over here, it is 6 into 5 into 4 divided by 3 into 2 into 1 into 5 into 4 divided by 2 into 1, and on solving this, the answer we obtain, it is equal to 200. Next is, out of 5 men and 2 women, a committee of 3 is to be formed. In how many ways can it be formed if at least one woman is to be included? So it is being given that at least one woman is to be included. So we are having two cases. First is, if one woman is included, and second is, if 2 women are included, because the maximum number of women we have, it is 2. So maximum we can include 2 women. So if 2 women, 1 woman is included, it means the number of men that is to be included, the committee is to be consist of 3 persons. So 2 men are there, and when 2 women are there, it means 1 man is there. Number of ways of choosing 1 woman out of 2 women, it is 2C1. Number of ways of choosing 2 men out of 5, it is 5C2, and the answers in this case, it is 2C2 into 5C1. So in this case the answer we obtain, that is equal to 2 into 10, that is equal to 20, and in this case the answer we have, it is 1 into 5 is equal to 5. We are saying either this thing can happen or this thing can happen. So by the fundamental principle of addition, the final answer we obtain, it is 20 plus 5, that is equal to, we have total 25 ways of doing this. Next question we have is, a committee of 5 is to be formed out of 6 men and 4 ladies. In how many ways can this be done if at least 2 ladies are included? So again we are having the case that at least 2 ladies are to be included. So the first case we are saying when 2 ladies are there. Second we are saying when 3 are there, and next we are saying when, third case we are saying when 4 ladies are there. Then the number of men we have, in this case we will have 3 men, in this case we will have 2 men, and in this case we will have 1 man. So the options we have total 4 ladies, so it is 4C2 into 6C3, then it is 4C3 into 6C2, then it is 4C4 into 6C1. The answer we have in this case, it is 1 into 6, in this case it is 4 into 15, and this case it is 6 into 20. So we are saying in this first case the total cases we have, it is 120, in this the total answer, total number of cases we have 60, and in this case it is 6. So by fundamental theorem of addition, these are 3 different cases we have. So by fundamental theorem of addition, the final answer we obtain, it is 120 plus 60 plus 6, that is equal to 186. We are saying we have total 186 different ways. So when we are saying at most 2 ladies are included, it means we are having the case first that 1 lady is there, and second 2 ladies are there. It is at most 2 means maximum 2 can be there. So if 1 lady is there, it means 4 men are there, and if 2 ladies are there, the answer we have, it is 3 men are there. The committee is to be formed with 5 persons. So in this case the answer we obtain, the number of ladies we have, it is 4C1 into 6C4, and over here the answer we have, it is 4C2 into 6C3. So 4C1 we have, it is 4, and 6C4 means we are talking about this 6C4, this is equal to 6C2. So this is equal to 6 into 5 by 2 factorial. So the answer we have, it is 15, that is equal to 60. And in this case the answer we have, it is 4C2 into 6C3, that is equal to 120. So by fundamental theorem of addition, the final answer we obtain, we are saying that either we can have this case or we can have this case. So by fundamental theorem of addition, the final answer we obtain, the total number of cases in this case we will have, it is 180, that is sum of both these. Next is, an examination paper contains 12 questions consisting of part A and B. Part A contains 7 and part B contains 5 questions. We have total, it is 12 questions. We have 2 parts, it is A and B. In part A we have 7 questions, in part B we have, it is 5 questions. A candidate is required to attempt 8 questions. A candidate has to attempt a total 8 questions, selecting at least 3 from each part. How many ways can candidate select these questions? So he should have at least 3 questions from each part. So we are saying, suppose he has selected from this part A, he has selected 1 question, then in that case from B he has to select 7 questions. This is not possible because from B there are maximum of 5 questions. Similarly, if we are saying that if he has selected 2 from part A, he has to select 6, this is also not possible. So at least he has to select 3 questions from part A, and he has to select then 5 questions from part B. Next case is he has to select 4 questions from part A, these two cases, these are not possible. Then he has to select 4 questions from part B. Then we are saying he has to select 5 questions from part A. He has to select 3 questions from part B. And if he selects, if we are talking about the case that he selects 6 questions from part A, he has to select 2 questions, and again this case is not possible. So these are the possible cases that we have, and the answer in all these cases, if he is selecting 3 questions, the answer is, out of these 7 questions he is selecting 3 questions, out of these 5 questions he is selecting 5 questions, and we are talking about the product of these values. Then out of 7 questions he is selecting 4, out of 5 he is selecting 4, out of 7 he is selecting 5, out of 5 he is selecting 3 questions. So the final answers we have, it is 7C3 into 5C5, then 7C4 into 5C4, then 7C5 into 5C3. The answers we have in this case, it is 5C5, it is 1. 7C3 means we are saying it is 7 into 6 into 5 divided by 3 into 2 into 1. These two gets cancelled. We have it is 35 into 1 is equal to 35. Next is 7C4 and 5C4. The answer we have it is 35 into 5, because 7C4 is equal to 7C3. Answer we have it is 175. Next is 7C5, means 7C2 we are talking about. So 7C2 is 7 into 6 divided by 2. So answer we have it is 21 into 5C3. 5C3 is 5C2. So it is 5 into 4 divided by 2. So it is 10. We have it is 210. So all these cases, these are different cases we are talking about. Either he has to attempt this, or he has to do this, or he has to do this. So by fundamental principle of addition, the final answer we have, the total number of cases we have, it is 420. So we are saying there are 420 ways to select these questions. Now the next question we have is, how many diagonals are there in a polygon of n sides? So suppose we are talking about a polygon in this way, and it is having say n sides. So we are naming these vertices as, say this vertex it is A1, this is A2, A3, A4, A5, A6, and suppose say this vertex it is AN. Some vertex is there, it is AN. So if we are talking about the diagonals, diagonal means if I am talking about this vertex A1 and I am joining this with A2, I am joining this vertex A1 to A2. So this will correspond to a side. If I join this A1 vertex to A3, I will obtain a diagonal. This is a diagonal. If I join this A1 to A4, I will obtain another diagonal. If I join A1 and A5, I will obtain another diagonal. So basically I am saying that if I have to represent the diagonals over here, I am talking about that A1, A3, this will represent a diagonal. A1, A4 will represent a diagonal, and so on. So we are talking about a polygon with n sides, and I list these n sides as n vertices we are talking about. It is A1, A2, A3, A4, so on up to AN. Then automatically it will have n sides. Now if we want to find these terms we have over here, it is n. We want to find, or we want to choose 2 vertices. I am talking about we want to choose 2 vertices out of these n vertices. Then the number of ways of doing so, it is NC2. Now if we choose all these vertices, we have seen that what these vertices, choosing these 2 vertices will represent, it will represent all these pairs we are talking over here. It is A1, A3, A1, A4, so on. But it will include the pair, we are saying A1, A2 also, which corresponds to a side. So we are saying this term that we are talking about, that this value NC2, this will correspond to diagonals as well as the sides. Now the number of sides we have, it is n. N is the number of sides of a polygon. So we are saying nc2 minus n. This will give us the number of diagonals. This will give us number of diagonals, and the value of this term we will have, it is n into n minus 1 by 2 minus n. So it is n into 1 by 2 we have taken common, it is n minus 3. So these are the number of diagonals in a polygon with side n. Next we have is, there are 10 points in a plane, and no 3 of which are in the same straight line except for except 4 points, that is 4 points which are collinear. So we have 1, 2, 3, 4 points are there which are collinear. Except for this, no other points we are saying they are collinear. No other point means no 3 other points they are in the same straight line. So we have to find the number of lines obtained from the pair of these points. So we are saying that if we want to draw a line by choosing the points, we have to choose 2 points. There are total 10 points, and there are 10 C2 ways to choose 2 points out of this. We are saying there are 10 C2 ways to choose 2 points. So we are saying, suppose we have chosen these 2 points, we can draw a straight line over here. Suppose we have chosen these 2 points, we can draw a straight line over here. If we have chosen these 4 points, we are talking about these 4 points, we can draw a straight line. Now look at the condition over here. If we join these two, we obtain one straight line. If we join these two, we obtain 1. If we join these two, we obtain 1. So when we are counting these 10 C2 ways, we are counting the lines in this way, that we have chosen these 2 points, we have chosen these 2 points, we have chosen these 2 points. So there are total 10 C2 lines that we can form. Now next, it is being given that there are 4 points which are collinear. There are 4 points which are collinear. So the number of line formed by joining the 4 points, taking 2 at a time, it is 4C2, that is equal to 6. So we are saying there are total lines we are counting, it is this, out of which the lines we are having because of these points, these 4 points, we are saying it is 6, and there is one line which passes through all these 4 points, we are saying plus 1. So the answer we have, that is equal to 10C2 means 45 minus 6 plus 1, that is equal to 40. So we are saying that there are 40 lines which can pass in this way. Next is the number of triangles that can be formed with vertices as these points. So now, if in place of the straight line we are talking about the triangles, triangles means that we have to choose 3 points. We have to choose 3 points. So there are 10 C3 ways to choose 3 points, out of which these 4 points which are collinear, we are saying they will not correspond to any triangle. So number of ways of choosing 3 points out of these 4 points, it is this much. So the total number of triangles we will have, 10 C3 is 10 into 9 into 8 divided by 3 into 2 into 1 minus 4 C3 means we are talking about 4 C1, that is equal to 4. So the answer we obtain, it is 120 minus 4 is equal to 116. So we are saying total 116 ways are there of forming the triangles with these points. Next is, a box contains 6 red and 5 white balls. In how many ways can 6 balls be selected so that there are at least 2 balls of each color? So it is at least 2 balls of each color. It means if we are talking about red and white balls, we are talking about there are 2 balls which are red, then we will have 4 balls which are white. If we have 3 balls which are red, then we will have 3 balls which are white. If we have 4 balls which are red, we will have 2 balls which are white. Now the total number of red balls we have, it is 6. We are saying that total number of red balls we have, it is 6. Total number of white balls we have, it is 5. So the total number of ways we have, it is 6C2, 6C3, 6C4. In this case it is 6C4, 5C4, 5C3, 5C2. Now if we take the product of all these terms, from this first term the answer we will have, it is 6C2, that is equal to 6 into 5 by 2 into 5C4 is 5. So the answer we will have, it is equal to 75. In the second case it is 6C3. The answer we will have on multiplying both these terms, we are saying 6C3, 6 into 5 into 4 divided by 3 into 2 into 5C3 means we are talking about 5C2, it is 5 into 4 divided by 2. So the answer we have, it is equal to 200. And in this third case the answer we have, it is 6C4. So that is 6C2. So it is 6 into 5 divided by 2 into 5C2, it is 5 into 4 divided by 2. The answer, it is 150. So either of these cases can happen. We are saying either this case can happen, or this second case can happen, or this third case can happen. So by the addition theorem, fundamental theorem of addition, we have the final answer is 75 plus 200 plus 150, that is equal to 425. So there are total 425 ways. Next is how many committees of 5 persons with a chairperson can be selected from 12 persons. So suppose we are saying first of all the chairperson is being selected. So the number of ways of doing so, it is out of the 12 persons we are choosing one person, and after this chairperson is being chosen, we are saying the number of persons we are left with is 11, and the number of persons in the committee that we have to choose, it is 4. So we are saying the number of ways we have, it is 11C4. So the answer we get, it is 12 into 11 into 10 into 9 into 8 divided by 4 into 3 into 2. These 2 gets cancelled. This is 3 3s are 9. So the answer we obtain, this is equal to 12 into 330, that is equal to 3960 ways. So there are total 3960 ways. Now the next question we have is, a bag contains 3 black balls, 2 white balls and 4 red balls. It is being asked that in how many ways can 3 balls be drawn from the box if at least 1 black ball is to be included. So we have the first case that there is 1 black ball. We are saying there is 1 black ball. Second, we are saying there are 2 black balls. And third, we are saying that there are 3 black balls. So when we are saying that there is 1 black ball, it means out of these black balls, 3 black balls, we have to choose 1 ball. And from the remaining 6 balls, we have to choose 2 balls. When we are talking about 2 black balls, it means out of these 3 black balls, we have to choose 2 black balls. And out of the remaining 6 balls, we have to choose 1 ball. Out of these remaining 6 balls, we have to choose 1 ball. And when we are choosing 3 black balls, so we are saying that we have to choose out of these 3 black balls, we have to choose these 3 balls. So the number of ways we have, the answer in this first case, that will be 45. This second case, the answer we have, it is 3 into 6, it is 18. And this third case, we have the answer, it is 3C3, that is equal to 1. So by the fundamental theorem of addition, the final answer we obtain, it is 45 plus 18 plus 1 is equal to 64. Next is, a group consists of 7 boys and 4 girls. In how many ways can a team of 5 members be selected if the team has no girls? When we are talking about the case that the team has no girls, it means 5 boys are to be selected out of 7 boys. A number of ways of doing so, it is 7c 5, that is equal to 7c 2. The answer we obtain, that is equal to 21. Next is second case is at least one boy and one girl. When we are saying at least one boy, it means one boy is to be selected, then 4 girls will be selected. Second case we can have it is 2 boys are selected and 3 girls are there. 3 boys are selected, 2 girls are there, and 4 boys are selected and 1 girl is there. We are saying there should be at least one boy and one girl. Now the number of boys, the total number of boys we have it is 7 and girls we have it is 4. So the answer we get it is 7c1 into 4c4. Next it is 7c2 into 4c3. Next it is 7c3 into 4c2, and last we have it is 7c4 into 4c1. So the answers for these cases we have it is, in this case we get it is 7. For next it is 7c2 and 4c3. So 4c3 we can write it is 4c1. So on solving this we will get the answer is 84. Next case the answer is 210, and next case we are saying it is 140. And by the fundamental theorem of addition, when we add all these values, because any one of these cases can happen, so the total answer we obtain it is, by adding all these values we get it is 441 options we have. The last part of this question it is at least 3 girls. So we are saying at least 3 girls means that 3 girls should be there, and if 3 girls are there then 2 boys will be there. If 4 girls are there then 1 boy is there. Maximum number of girls it is 4. So answers in this case it is, the values we have in this case, we are saying the number of girls it is 4c3 into 7c2, and it is 4c4 into 7c1. This 4c3 means we are talking about 4c1. So the answer we get it is, this value we obtain it is 84, and the answer we get from this it is 4c4 means it is 1 into 7c1 it is 7. So we will have the value over here it is 7. So the final answer we obtain it is 84 plus 7, that is equal to 91. So these are the number of cases in this case. Next is a bag contains 6 white marbles and 5 red marbles. It has 6 white marbles and 5 red marbles. Find the number of ways in which 4 marbles can be drawn from the bag. First case we have is they can be of any color. So total number of marbles we have it is, the total number of marbles we have, that is equal to 11. The marbles we have to choose it is, 4 marbles. So we are saying the number of ways of choosing 4 marbles out of 11 it is 11c4, and the value comes out to be 11 into 10 into 9 into 8 divided by 4 into 3 into 2 into 1, and on solving this the answer we obtain it is 330. Next case we have is that 2 white marbles and 2 red marbles are there. So when we are saying there are 2 white marbles, it means out of 6 marbles we have to choose 2, and out of the 5 red marbles we have to choose 2. So the answer we have over here 6c2, 15 into 10, the value we have it is 150. The last case we have, they must be all of the same color. So if they are all of the same color, it means we are talking about 2 cases. First is that all are white, and second case we are saying that all are red. So if all marbles are white, we have to choose 4 marbles. It means out of these 6 marbles we have to choose 4 marbles. The answer for 6c4 it is 6c2, that is equal to 6 into 5 by 2. So we get it is equal to 15, and all are red. When all are red, it means out of the 5 marbles we have to choose 4. So it is 5c1 that is equal to 5. So by fundamental theorem of addition, we are saying that either of these two cases can happen, either all are white or all are red. So by fundamental theorem of addition, the answer we have, it is 15 plus 5 that is equal to 20. Next is, we wish to select 6 persons from 8. But if the person A is chosen, then B must be chosen. In how many ways can the selection be made? So we are having two cases now. First case is that if A is chosen, and second case we have is if A is not chosen. I think A is not chosen. So if A is chosen, it means one person A is being selected, B is automatically being selected. We have total 8 persons and we have to select 2. We have already selected 2 persons. Now the number of persons we are left with is 6. Now out of these 6 persons, we have to choose 4 persons. 6c4 is equal to 6c2, that is equal to 15. Second case, we are saying if A is not chosen, then the number of persons left over here, we are saying we have now 7 persons left, out of which we have to choose 6 persons, and number of ways of doing this, it is 7c6 that is equal to 7c1 that is equal to 7. So again we are saying either case 1 can happen or 2 can happen. So by fundamental theorem of addition, the total number of cases we can have, it is 15 plus 7 is equal to 22. So we are saying there can be maximum 22 cases in this case. Next is, find the number of ways of choosing 4 cards from a pack of 52 cards. So the number of ways we will have over here, it is 52c4. We have to choose 4 cards out of 52 cards, and if you solve this value, you will obtain the answer as 270725. Next is, in how many of these 4 cards are of the same suit? So when we are talking about the same suits, we have 13 cards of the same suit of each type. So we are saying, suppose all four cards, first case we are saying they are diamonds, second case it can be spades, third case it can be club, and fourth case it can be heart. So how many diamond cards are there? It is 13 cards are there, and we have to choose out of these 13 cards, we have to choose 4 cards. So we have 13c4 option. Similarly for spades, for clubs or hearts. So any of these 4 cases can happen. So the final answer we obtain, it is sum of all these values. So it is 4 into 13c4. Or this thing you can see in this way. We are saying that we are having 4 different suits. So first, if all, we have to make the choice out of these 4 different suits that we have. So we are saying the number of options of doing so, it is 4. Suppose we have chosen any one of these, then we are saying in these option we have further 13 cards, and out of these 13 cards we have to choose 4 cards. This is the next step that we have. So we are saying that it is 4 into 13c4, and the answer on solving this we will obtain, it is 2860. Next is second part. We are saying 4 cards belong to 4 different suits. So it means that from each suit we require 1 card. From diamonds we require to choose 1 card. From spades we require to choose 1 card. From clubs we require to choose 1 card, and from heart we require to choose 1 card. So the answer we have, it is 13 raised to the power 4. So these are the number of ways in this case. Third is, 4 cards are face cards. Now the number of face cards we have, it is, when we are talking about face cards, the number of face cards, it is 12. We want to choose 4 cards out of these face cards, so answer we have, it is 12C4, and the value of 12C4, it is 495. Next case we have is that 2 cards are red and 2 cards are black. Number of red cards we have, it is 26. Number of black cards we have, it is 26. So the answer we have, it is 26C2 into 26C2. So the value we obtain, that is equal to 26C2 means 26 into 25 by 2 square, and on solving this, the answer we obtain, it is 105,625. Now the last part we have is the cards are of the same color. So when we are talking about the cards are of same color, it means either all the 4 cards they are red, or we are saying all 4 cards are black. So when we are saying 4 are red, it means we have to choose 26C4, and over here the value we have, it is 26C4, and by fundamental theorem of addition, we are saying either this case can happen or this case can happen. So by fundamental theorem of addition, the answer we have, it is 2 times 26C4, and if you solve this value, the answer you obtain, it is 29,900. So these are the number of ways of choosing the 4 cards of same color. Next is from a class of 25 students, 10 are to be chosen for a party, and there are 3 students who decide that either all of them will join or none of them will join. In how many ways these can be chosen? So first case we have is that these 3 persons, we are saying, we are considering them as one entity. So the number of students, we are saying, there are total 25 students, out of which we are considering these 3 students as one student. So number of students left over here, it is 22 students. Number of students left, it is 22 students. So first case we are saying, if these 3 students they join, or second case we are saying that these 3 students they do not join. So if these 3 students they join, so it means there is one case that all these 3 students have joined. Now out of the remaining 22 students, we have to select, we have selected 3 students, we have to select 7 students. So we are saying that the total number of cases we have, it is 22C7. In the second case, we are saying that if these 3 students they do not join, it means out of the 22 students, we have to select 10 students. Again, either this case can happen or this case can happen. So the answer, the final answer we obtain, it is by fundamental theorem of addition. The answer we get, it is 22C7 plus 22C10, and if you solve both these values, the answer you obtain, it is 817,190. This is the answer you obtain in this case. Now the next question we have is, a boy has 3 library tickets and 8 books of his interest in the library. So we are talking about, there are 8 books of the interest in the library. Of these 8, he does not want to borrow mathematics part 2. One of these books, it is mathematics part 2, and he does not want to borrow that book unless mathematics part 1, there is another book, that is mathematics part 1 is there, is also borrowed. He will borrow mathematics part 2 if mathematics part 1 is, he will borrow. In how many ways can he choose the 3 books to be borrowed? So he has to choose 3 books. So in the first case we are saying, suppose he borrows mathematics part 2. Now first case we are saying he borrows mathematics part 2. So in this case, the total number of options he has to choose mathematics part 2. He has to choose mathematics part 2. Automatically he has to choose mathematics part 1. The remaining number of books now he has, it is 6. Now out of these 6 books he has to choose only 1 books, because he has already borrowed mathematics part 1 and mathematics part 2. So the total number of ways he has, it is 6C1, that is equal to 6 ways. Now the second case we have is, he does not borrow mathematics part 2. We are saying he does not borrow mathematics part 2. Then in this case, how many books are left now? It is 7 books are there, and out of these 7 books he has to choose 3 books. We are saying he has 3 library tickets, so he has to choose 3 books. So the answer we have in this case, it is 7C3, that is equal to 7 into 6 into 5 divided by 3 into 2 into 1. These two gets cancelled, it is 35 ways. And by the fundamental principle of addition, the answer we have, it is 35 plus 6 is equal to 41 ways. There are total 41 ways to do this. Next is, a convex polygon has 44 diagonals. Find the number of its sides. Now we know that the number of diagonals, if we have polygon with n sides, it has nc2 minus n diagonals. So if a polygon has 44 diagonals, so we are saying this is equal to nc2 minus n. This is equal to n into n minus 1 by 2 minus n. This value 44 we have, minus n, this value is equal to 44 we have. Now if we solve this equation, we will obtain from this equation we are talking about, if we simplify this, we will obtain n square minus 3n minus 88 is equal to 0. And on solving this, we obtain two values of n, one is minus 8 and one is 11. We are talking about polygon, so it means this value minus 8 is not possible. So we are saying that the polygon should have 11 sides. When this polygon has 11 sides, then in that case it will have 44 diagonals. Next is, if m parallel lines in a plane are intersected by a family of n parallel lines, there are m parallel lines, say these are m parallel lines, these are intersected by n parallel lines. For these lines we are saying these are n parallel lines. Find the number of parallelograms formed. So if we look at this case, the parallelogram will be formed. What we have to do is, we have to choose 2 parallel lines out of these m lines. The number of ways of choosing 2 lines, it is MC2. If we choose any 2 lines, we obtain 2 parallel lines in this way. Out of these n lines, we have to choose 2 parallel lines. Number of options of doing this, it is NC2. So the total number of options, the total number of parallelograms we have, we are saying we choose 2 parallel lines from this, we can choose 2 parallel lines from this. So total number of options we have, or the total number of parallelograms we obtained, it is equal to MC2 into NC2. And on solving this, on simplifying this value, you will obtain the answer in this form. You will obtain the answer in this form, that it is m into n into m minus 1 into n minus 1 divided by 4. So these are the total values that we have. Next is, in an examination, a candidate has to pass in each of the 5 subjects. In how many ways can he fail? So the candidate will fail if he will fail in one subject, if he will fail in 2 subjects, or in 3 subjects, or in 4 subjects, or in all 5 subjects. Now number of ways of choosing one subject out of 5 subjects, it is 5C1, this is 5C2, this is 5C3, this is 5C4, this is 5C5, this value is equal to 5C1, this value is equal to 5C2. So the total number of options we have, it is sum of all these values. The answer in this first case it is 5, in this second case it is 10, this is 10, this is 5, and this is 1. So the total number of options we have, it is 31. So there are total 31 ways in which he can fail. Next is determine the number of 5 card combinations out of deck of 52 cards if there is exactly one ace in each combination. So we are saying that we have total 52 cards, out of which we have number of ace, it is 4. Now it is being given that one ace is always there. So ways of choosing one ace out of 4 cards, that is equal to 4C1. Now if one card is already being chosen, we have to choose total 5 cards. Number of aces, it is 4. Now the remaining cards, it is 48. So we are saying that the number of ways of choosing a non-ace card out of this 48 cards, it is 48C4. We have to choose 4 cards now. So the answer we obtain, it is by fundamental theorem of multiplication. We are saying the final answer we have 4C1, that is equal to 4. So the final answer we have, it is 4 into 48C4, and the value of 48C4 you can obtain, it is 194580, and you multiply this value with 4, you obtain the answer as 77830. Next is, in how many ways can one select a cricket team of 11 from 17 players in which 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers? So it means we have two kind of players. One is bowlers, and second, suppose we are saying they are the batsmen. The number of bowlers we require, it is exactly 4. So the number of batsmen should be 7. Total number of players who can bowl, it is 5, and the remaining players we are talking about, there are 12 remaining players. So we are saying that out of these 5 bowlers we have to choose 4. Out of these 5 bowlers we have to choose 4, and out of these 12 remaining players we have to choose 7 players. So this is equal to 5C4 into 12C5. The answer we have 5C4, it is 5C1 basically. So answer we have, it is 5 into, and if you solve 12C5, the answer you will have, it is 792, and on multiplying these numbers you will get, it is 3960 ways. So there are total 3960 ways of selecting such a team. Next question we have is, a committee of 12 persons is to be formed from 9 women and 8 men. In how many ways can this be done if at least 5 women have to be included in the committee? So when we are saying that at least 5 women should be there, it means that the cases we have, it is there are 5 women and we require 12 persons. It means in this case we will have we have 5 women, then we will have 7 men. This is the first case. Second is we have 6 women and 6 men. Then we have 7 women and 5 men. And then we have 8 women and 4 men. and last case we have it is 9 women and 3 men. Now the total number of men we have it is 8 and total number of women we have it is 9. So in each of these cases the answer we have it is 9C5 into 8C7, then it is 9C6 into 8C6, then it is 9C7 into 8C5, then 9C8 into 8C4, then 9C9 into 8C3. Now if we calculate the values in all these cases, the answers we will have in this first case, when we calculate the value, the answer we have it is 1008. In this second case we have it is 2352. In this third case we have 2016. Next we have it is 630 and last it is 56. Now any one of these cases can happen. So we are saying the total cases, the sum of all these cases we have it is 6062. So this is the answer for this part. Now next it is being asked, in how many of these committees the women are majority? The women in majority are there. So when we are saying the women are in majority, it means we are talking about this second and this third case. So the sum of these values in this case, it is, we are talking about it is 2016 plus 630 plus 56. The answer we have it is 2702. So in these many cases the women are in majority. Now the next case we have is the men are in majority. The last part it is being the men are in majority. So clearly if we look at these cases over here, men are in majority in this first case only. In this second case, both men and women, they are equal in number. So we are saying in these many cases the men are in majority. So the answer we have, the men are in majority in 1008 cases. Out of these all cases, we have 1008 cases in which men are in majority. In this next question, it is being given that in a village there are 87 families, of which 52 families have at most 2 children. Then in a rural development program, 20 families are to be chosen for the assistance, of which at least 18 families must have at most 2 children. In how many ways can these be chosen? So if we list these things over here, we are saying the total number of families we have it is 87. We are saying there are families with, we are talking about families with at most 2 children, that is equal to 52. So families with more than 2 children, that is equal to 87 minus 52, that is equal to 35. Now what we have to do is we have to choose the families in such a way that 18 families must have at most 2 children. So we are saying out of these 52 families, we have to choose 18 families. We are saying out of these 52 families, we have to choose 18 families. This is the first case, because it is being given that for assistance that at least 18 families must have at most 2 children. So when we are saying that we have chosen 18 families with 2 children, then we will choose 19 families with 2 children, and then we will choose 20 families with at most 2 children. So when we are talking about this case, so we get it is 52C18 into the 2 children are to be selected out of this 35. So we are talking about the case 35C2. Second, when we are talking about 19 are chosen with at most 2 children. So we are saying it is 52C19 into 35C1. And the last case we are saying that 20 families should have at most 2 children. So we are saying the answer we have it is 52C20 into 35C0. No family is to be chosen out of these. So the answers we obtain over here, we are saying it in this first case, the answer we will have it is 52 into 51, so on up to how many terms we will have? It is 18 terms we will have divided by 18 factorial. So it is not feasible to manually calculate these answers. So we leave them as it is. So we are saying the total number of cases we have now. These are all separate cases. Either this thing can happen, or this thing can happen, or this third case can happen. We are saying any one of these three cases can happen. So we are saying by the addition theorem or by the fundamental theorem of addition or fundamental principle of addition, the sum of all these values, will give us the final answer. Now the next question we have is that in how many ways can 19 identical books on English and 17 identical books on Hindi can be placed in a row on a shelf so that two books on Hindi may not be together. So suppose we are arranging these books. We are talking about the English books we are representing with E and the Hindi books we are representing it with H. Then these English books we are saying these can be arranged in this way, that we have English book, then a empty space is before English book, then next again we have English book, then an empty space is there, English book, then an empty space is there, so on like this, then an empty space is there, English book, and an empty space is there. Now the total number of English books we have, it is 19. Now if we count these numbers of empty spaces we have, we are saying this is first English book, corresponding to this is the first empty space. This is second English book, this is second empty space. This is third English book, it is third empty space. Likewise, this is the 19th English book, so this place corresponds to the 19th empty space. And this first space, if we add over here, we are saying the empty spaces now we have, it is equal to 20. Now on these 20 empty spaces, the 17 Hindi books are to be placed. And the ways of doing this, we are saying out of these 20 spaces, we have to choose 17 spaces. This is equal to 20C3. This is equal to 20 into 19 into 18 divided by 3 into 2 into 1. And on solving this, we get it is 1140. So these are the number of ways in which these Hindi books can be placed in these empty spaces. And there is only one way to arrange the English books over here. So the total number of ways we have, it is 1 into 1140, and the answer we have, it is 1140. This is the final answer we obtain in this case. Next is the number of ways or combinations of n different things. Selecting at least one of them is 2 raised to the power n minus 1. So when we are saying we have total n things and we are selecting at least one of them, we are having total n things and we are selecting at least one of them. So when one object is selected, the number of combinations we have, it is nc1. When two objects are selected, the number of options we have, it is nc2. When three are selected, the number of combinations we have, it is nc3. Likewise, when all the n are selected, the number of options we have, it is ncn. So by the fundamental principle of addition, because these are all different cases we have, by fundamental principle of addition, the answer we obtain for this, it is nc1 plus nc2, so on up to plus ncn. Now if we add nc0 and subtract nc0 from this, the value of this term we are saying, the value of this term we have, it is 2 raised to the power n, and nc0, that is equal to 1. Why this is 2 raised to the power n? This will be more clear to you when we will do our next chapter on binomial theorem. Or this similar kind of result we have already proved in our first chapter when we are talking about all the subsets. So we are saying if we count the number of subsets of n different objects, it is 2 raised to the power n. But when we are talking about all subsets, then phi is also there. It means we are not choosing anything. So in this question it is given that at least one is to be selected. It means this case is not there. So we are saying we have to remove an element from this. So the total number of elements we have, it is 2 raised to the power n minus 1. This is explained over here. So we are saying that the total number of ways of selecting one or more of the n different things is 2 raised to the power n minus 1. Or you can use this kind of result that we are using the combinations, then we are using the fundamental principle of addition, then we are using the result that sum of all these coefficients, binomial coefficients, we are saying nc0 plus nc1 so on up to ncn, the sum of all these values, it is 2 raised to the power n. The proof of this thing we will do in our next chapter of binomial theorem. Now the next question we have is, Mohan has 8 friends. In how many ways he can invite one or more of them to dinner? So if we are saying Mohan has 8 friends and the number of options we are talking over here, it is, when we are talking about his first friend, either he can invite that friend, he has 2 options, either he can invite that friend or he cannot invite that friend. So we are saying there are basically 2 options. Coming to the second friend, he has 2 options. Coming to the third friend, he has 2 options. And likewise, if we continue up to 8th friend, again he has 2 options, either he invites that friend or he doesn't invite that friend. So the total number of options we have over here, it is product of all these terms. So it is 2 into 2 into 2, that is so on up to 2, it is 8 terms are there. So it is 2 raised to the power 8. But when we are talking about this case, we are having an option. We are saying either he invites that friend or he does not invite that person. We are having a case when none of them is being invited. When we are saying that there are total 2 raised to the power 8 cases, so we are saying that none of them is being invited. But it is being given that invite one or more to the dinner. It means at least one is to be invited. So this case cannot be there. So we are saying the total number of cases we have, it is 2 raised to the power 8 minus 1, that is equal to 255. Another way to look at this answer, it is that out of these 8 friends he can invite one friend, or out of these 8 friends he can invite 2 friends, or out of these 8 friends he can invite 3 friends, so on up to out of these 8 friends he can invite 8 friends. We have already seen the value of this term, it is 2 raised to the power 8 minus 1, and the answer for this, it is 255. Next is, there are 3 books of physics, 4 of chemistry and 5 of mathematics. How many different collections can be made such that each collection consists of one book of each subject? When we are saying there is one book of each subject, it means out of 3 books of physics we have to choose one, out of 4 books of chemistry we have to choose one, and out of 5 books of mathematics we have to choose one. The product of all these, it is 3 into 4 into 5. The answer we have, it is equal to 60. Next, the second case we have is at least one book of each subject. So in this case, we are saying what this thing means is that there is at least one book of mathematics, then at least one book of physics, at least one book of chemistry. We are saying at least one book of chemistry. So when we are talking about the case that there is at least one book of mathematics, it means the number of options we will have, the total number of mathematics book we have, it is 5. So we are saying it is 2 raised to the power 5 minus 1. We are having the case at least one book of mathematics. When we are saying at least one book of physics, the options we have, it is 2 raised to the power 3 minus 1. And at least one book of chemistry means 2 raised to the power 4 minus 1. and the product of all these three terms, will give us the final answer. That is, the total number of cases we have, it is 3, 2, 5, 5. The product of these values, 2 raised to power 5 minus 1, 2 raised to power 3 minus 1 and 2 raised to power 4 minus 1. The final answer we obtain, it is 3, 2, 5, 5. And the last case we have over here, at least one book of mathematics. Last case we are saying it has at least one book of mathematics. So when we are saying at least one book of mathematics, it means we have 2 raised to the power 5 minus 1. Then out of the remaining books, how many books we have? It is 3 plus 4 is equal to 7. We can have any number of books. There may be 0 books, there may be 1 book, there may be 2 books, there may be 3 books. So the total number of cases we have, it is 2 raised to the power 7. So the answer we obtain in this case, it is 31 into 128, that is equal to 3968. So these are the total number of cases in this case. Next we have some mixed problem based upon permutations and combinations. So the first is, out of 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed? So we are saying that we have 7 consonants and 4 vowels. We have to choose, when we are doing this thing, we have to choose out of these 7 consonants, we have to choose 3 consonants, and out of these 4 vowels, we have to choose 2 vowels. So the answer we obtain, it is 210. So we are saying the number of groups each containing 3 consonant and 2 vowels is equal to 210. Now after choosing these 3 consonants and 2 vowels, we have to construct the words. After choosing this, we have to construct the words. Now we are saying we have 5 letters. We can choose these 5 letters in 210 ways. We have these 5 letters, and from these 5 letters, there are 5 factorial arrangements of these 5 letters that can be formed. So the total number of words we are saying, the total number of words that can be formed, it is 5 factorial into 210, that is equal to 120 into 210, that is equal to 25200. So we are saying there are total number of words that can be formed, it is 25200. Next is, the English alphabet has 21 consonants and 5 vowels. How many words with 2 different consonants and 2 different vowels can be formed with the alphabets? So again, we are saying we are choosing 2 consonants out of 21 consonants first. So the number of options we have, it is 21C2, and then we are choosing 2 different vowels. So the options we have, it is 5C2. So we are saying we have these many options to choose 2 consonants and 2 vowels. We have these many options. Now when we have chosen these consonants and vowels, we are saying we have basically chosen 4 letters, and from these 4 letters we can form 4 factorial arrangements. We are having now 2 consonant, 2 vowels. We are saying basically we have 4 letters, and from these 4 letters we can make 4 factorial arrangements. So we are saying what we have done, first step we have done, we have chosen 2 consonants and 2 vowels. Second step, we are saying we have arranged these letters. So from fundamental principle of multiplication, these are the steps we have. This is the first step, then followed by this is the second step. So we are using fundamental principle of multiplication, and the answer we obtain, it is 21C2 into 5C2 into 4 factorial words that can be formed. And when we solve these values, the answer we obtain for this, it is 2100 into 24, that is equal to 50400. So these many words can be formed. Next is how many words with or without meaning, each of 2 vowels and 3 consonants, can be formed from the letters of the word daughter. So if we look at these words, we have 3 vowels and we have 5 consonants. So total number of ways of choosing 2 vowels and 3 consonants, the total number of ways of choosing 2 vowels and 3 consonants, it is 3C2 into 5C3. On solving this, the answer we obtain, it is 30. Now it is being given that we have 2 vowels and 3 consonants we have chosen. So the total number of letters we have chosen, the total number of letters we have, it is 5. These 5 letters we can have 5 factorial arrangements. So total number of words that can be formed, it is, first of all, we have 30 ways to choose these 5 letters, and these 5 letters can be arranged in 5 factorial, that is 120 ways. So the final answer we obtain, it is 3600. The final answer we obtain, it is 3600. Next is how many words with or without meaning can be formed using all the letters of the word equation at a time so that vowels and consonants occur together. So in this word equation, we have 5 vowels and we have 3 consonants. So the number of ways in which these 5 vowels can be arranged, the number of ways in which these 5 vowels can be arranged, it is 5 factorial. And number of ways in which these 3 consonants can be arranged, it is 3 factorial. Now suppose these 5 vowels we are saying, we are considering them as one word or one letter, and these 3 consonants we are considering them as one letter. We are saying this letter, we say it is denoted by star, and this we denote by plus. Now how many arrangement with these 2 elements can be made? It is 2 arrangements can be made. Either vowels can be placed first and then the consonants can be placed, or we are saying the consonants are placed first and then the vowels are placed. These are representing all the 5 vowels, all the 3 consonants. So the total number of options we have, what we are saying, we have collected these in 2 ways. There are 2 ways of doing this. Then the arrangement, the number of arrangement for the vowels we have, it is 5 factorial. The number of arrangements we can make for these consonants, it is 3 factorial. So the total number of ways we have, it is 2 into 5 factorial into 3 factorial, and the answer we obtain, it is 1440. So these are the number of ways we are saying of choosing of making the word so that vowels and consonants they occur together. So these are the number of ways. Next is, in how many ways can 5 girls and 3 boys be selected in a row so that no 2 boys are together? So if we are arranging these girls, we are saying G, 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 G and G. These are the 5 girls we have arranged. Now the number of positions for the boys we have, it is 1, 2, 3, 4, 5, 6. And it is being given that no 2 boys are together. So it means that for the girls we are saying, we have these 5 positions. So the girls can be arranged in 5 factorial ways. We are talking about the position of the girls. Girls can be arranged in 5 factorial ways. Now for the boys we have 1, 2, 3, 4, 5 and 6 positions. It is being given that they are to be seated in a row. So we are talking about into. Now the boys, number of boys we have it is 3. So out of these 6 positions we have to choose, we have to arrange 3 boys, and we are using permutation over here because the ordering of the boys, it matters over here, that which boy is given which position, it matters over here. So the answer we obtain, it is equal to 5 factorial into 6 factorial by 3 factorial. This is equal to, when we calculate this value, we will get it is 120 into 6 into 120 divided by 6. On multiplying these two values, we will get 14400. So we are saying the number of options we have, it is 14400. So in these kind of questions, we must keep in mind that when we are talking about we have to form a committee or we have just to choose the boys, we were using combination over there. But now it is being given that they are to be seated in a row. So it means that ordering is important over here. The ordering of the boys, it is important over here, and that is why we are using permutations in this particular case.